My historical musical instrument reproduction. I've got 2 case studies and I've got some thoughts about all of that. Now, usually the crowds I'm talking to, well not crowds, but have a lot of knowledge about specialist musical instrument things, but not very much knowledge about digital modelling or anything like that. So I'm going to try and change my tack from my usual game to be more about the objects and my results rather than the actual processes, because you probably don't really care about the processes so much. To set the scene about historical manufacture, it's not actually that old. Really, for music, it's only really about 100 years old. You could say that some people have been making instruments in old styles before, but that's a completely different thing. If you look at neoclassical designs of musical instruments, like this lyre guitar from the 19th century, it's not historical reproduction, it's just a 19th century guitar made for 19th century guitarists in the shape of a Greek lyre. It's got nothing to do with Greek lyres. They weren't trying to reproduce ancient Greek culture or anything like that. So I'm really talking about the early music scene and then the desire to reproduce music on historic instruments and how we go about that. Not historical reproduction. The kind of manufacture I'm talking about is typically carried out by small numbers of people, 1 or 2 people in a workshop. And when you think about musical instruments, there are so many materials involved in an instrument. You've got if in the guitar you have the wooden parts, often you have metal tuning gears and things like that. I'm going to be getting onto my reproduction tuning gears later on. I'm also not going to be talking about industry. There's some great stuff going on for modern instruments and actually factory-produced early musical instruments. I'm not really going to be talking about that. I'm going to be talking about small instruments. And I'm going to spare you my criticism for the hype that really has destroyed a lot of people's confidence in the early music instrument building scene in 3D technologies like 3D printing and whatnot. Now, my training was quite traditional. When I learned how to make plans of instruments, it was with pen and paper, and it was only really over the last 10 years as I've been doing just various things, trying to get by. I've learned I started using computer-aided design, and then really in the last couple of years I've started drawing in 3 dimensions using software that I can get quite cheaply as a student, as a PhD student at the University of Edinburgh. But it's revolutionised the way I build instruments, even in a traditional way, using traditional tools. I'm going to not go into that just yet. So case study 1. The Tasting guitar. I've got a really big white screen to dazzle you there. This instrument, there are only 2 surviving objects in the world. One's at the Met Museum in New York, one's at a private collector's collection in South Germany. I've seen them both, I've drawn them both. I hope there's others that I can find later, but these are the only ones that I really know about. And I went and made full-scale drawings of this thing, and I've got a little animation which I'm going to be talking over, which shows this instrument. It's quite a hard concept for people to grasp, usually. It has a piano hammer mechanism on the inside, and the piano hammer mechanism can be drawn out of the guitar. The hammers strike the strings through a small hole in the soundboard, as you can see there. And when I'm trying to communicate this to people, it's great to have a nice graphic. So as a PhD student, this is quite good to be able to have this animation. You can see the mechanism is pretty standard for piano mechanisms of the time, which, to be honest, weren't really standardized. All sorts of designs were used. It could be drawn out so you can make fine adjustments and tweaks to the way the mechanism works. Now, here's the original object. Very beautiful guitar. in the hands of a private collector in Germany. Now I'm building a copy of this instrument because my thesis in a nutshell is we don't really know what these sound like, let's make one and hear it. And I've been heavily relying more and more, and actually just really experimenting with 3D digital technologies, drawing them, and using 3D printing. I've had a grant from Shapeways to experiment with some things. This is a complex object. When you're working with the guitar, when you're reproducing an instrument like this, anyway, you're going to have to be working with small tolerances, the height of the string over the sound board, the spacing of the strings, the position of the bridge, all affects the tuning and the intonation. And from the musician's point of view, who hopefully will one day be playing my instrument, that's the most important thing, making sure that they can play it and that it sounds musical to their expectations. Also, I will need to make it sure that I'm faithful to the original object. But this has the added complication of a mechanism that can be drawn out. You can just see it peeking out the bottom of the instrument there, which some of you might be able to see. You put your hand inside. So this mechanism is inside the body, and it has to be in a position that can strike each string in the right place through a small hole in the soundboard. Now, I'm a one-man operation in reproducing this thing, but I have at my disposal a whole wealth of manufacturing possibilities. I need to keep the pace going. Right. So, having a 3D digital model of this instrument is so useful to be able to get all of those interlocking factors to align, to be able to get that hammer onto that string for the final version. Here's a 3D printed mechanism I made, which I've been using and showing people and talking about for quite a while now, well, for a few months. And it works. You can flick it, and the hammers work, and you can work it on a real guitar, and you can hear something to what it sounds like. And since I don't have access to the instrument in private hands, it's great to be able to have an object that I can use and have the experience of having assembled it and whatnot. I'm going to leave this instrument for now. Case study 2. Preston guitar tuners. Now, I don't imagine anybody here is going to know what this is, but I'm talking about 18th century guitar here, guitar with 2 T's. Now, a guitar with 2 T's is typically this instrument here. This is at Bern's Birthplace Museum, National Trust property. And this is presumably Robert Burns' guitar with 2 T's. 10 strings, wire strings, wooden friction tuning pegs. You don't need to know much about musical instruments for me, just hopefully to convince you that you have to readjust the tuning an awful lot on instruments like this. Metal strings with wooden pegs, which are essentially wooden cones pushed into conical holes. It works, it's one thing with 4 strings of a violin with guts, strung with gut, when you compare that with 10 strings of a metal instrument. In about 1770, this was changed. This instrument probably is earlier than 1770 because this design transformed the entire guitar making field. And we had something a bit like this, which all 10 strings could be housed in a very small little brass box, about 15 millimeters square. And the principle is quite simple. You have a little watch key that could go in, you turn the key, the sharpener moves up, and you can change the tension of the string. It was very effective, took the market by storm. All guitars had this, lots of them were retrofitted with this mechanism. I've been trying to build one of these for such a long time now. I think I tried this in 2009 first, and I made a wooden, this is my photograph from probably around that time, I made a wooden version, had it cast by a foundry in brass. It failed hopelessly. And I put so much work into it, invested so much money and time into this that I felt really gutted when I walked away empty-handed. And I had forgotten about it until I started experimenting with my 3D printing grant. And being able to print with wax and the casting in brass, I was able to produce functioning Here's my digital model. A functioning brass replica, completely to scale, completely functioning. Most of the parts were printed. Here's the Traveller, which I had to tweak. Obviously, there was plenty of work that needed to be done once I got the cast back. And moving swiftly on, here's my final object. Very happy about that. Now, the final object that I was able to get, I'd been trying. I'd given up because John Preston, working in the 1770s, had a large workforce. These parts were probably not made in his main workshop. They probably went through many hands, and hands that were skilled with a particular job. Probably one person drilled that hole, another person that hole, and they had specialist tools and equipment. When I did my tour of London at the time, going around different workshops and foundries, asking if people could help me, the answers were all very negative or very expensive. So I knew that they did it. You can do it, because they did it in 1770s, so surely we can do this today. And anyway, bottom line is, on this case study, that I had a fully working final object. I can see my time's running out. On reflection, 3D printing, 3D modelling, even 3D animation are great tools within the tool set of historical instrument manufacture. They don't go against tradition in that John Preston wasn't one person working lovingly on each instrument in his workshop, as we might romanticise about instrument making often. But he had at his disposal a workforce. I don't. But I have the power now of a workforce through these different technologies. I think the services like Shapeways and 3D Hubs, which offer these mail, what we call it, sent to you in the post, a bit like Amazon, but for 3D printing. This opens so many doors for myself, where I can't afford to have an outlay outgoing cost. And for people in academia, which I'm addressing right now, this is a big deal because we have our specialisms, we have our niche, and now we have not only our niche, but a big outlet into we all have our niche, but we have the power of a workforce, a large workforce. I need to make sure I stick to my points. On questions of authenticity, there's nothing lost by thoughtfully incorporating these technologies within already diverse and modernised workshops. I say I use traditional tools. That's not true. I'm electric powered, and I use all sorts of machines in my workshop which are advantageous. Most makers that history has observed had access to workforce. To produce elements of functioning instruments, there needs to be an intimate working knowledge of the object. End product manufacture from companies like Shapeways offers significant possibilities for makers. Anyway, I'm very happy to have this opportunity to speak to you. If you have any questions, there's the Q&A in a few minutes. Also, feel free to send me an email if you've got anything you want to ask me. Thanks very much.